Hello and welcome to Cap Academy. In this video we're going to be going over 3Shape's denture design workflow. But first I want to pull up the order form. For dentures, you're going to select all of the teeth you want involved and set it up as denture gingiva and artificial teeth for each unit. Under gingiva, you do have some extra options that you need to decide under the plus sign. Under this type menu, there are a bunch of different options that change how the final STL files will come out. There are three main types of these. The first is injection molding, which will produce one STL file that includes both the denture base and the teeth all as one file. This is used for an injection molding process or for a try-in denture. All of the other options are glued-in teeth, meaning it's going to produce an STL file for the base with sockets for pre-manufactured teeth. There are two types of these, however. Basal reduction and manual reduction are a method that have you glue in the denture teeth and then grind away from the underside if the tooth was placed too low. This means that the final STL file for your denture base is allowed to have holes and go below a minimum thickness. For the last three options, com, arch, and matrix, those are still producing sockets for the teeth, but it is maintaining a minimum thickness. This means that if I place my teeth too low close to the tissue, I may need to grind away at the teeth before I can glue them into the socket. I'm going to use one of those options, matrix, and then go ahead and save. I'm going to skip the scanning workflow for right now, but keep in mind that it requires both arches for almost every case, and it needs something that acts as a wax rim. It doesn't necessarily have to be a real wax rim, it could be anything that holds it in occlusion. Once the design is opened up, our first step is to mark an occlusal plane using 3 points. It doesn't matter exactly where you mark them, but I'm just going to place them all on the little edge between the two wax rims. Once it's placed, wherever you happen to mark it, you'll want to turn off your wax rim at least most of the way, so that you can make sure that this tooth chart is lined up correctly. You'll be able to move them later on, but the initial teeth placement is going to be based off of this tooth chart. Once you're happy with that position, you can continue next and mark all of the anatomical points. These points don't have to be placed super exact. As long as they're roughly in the correct area, it should be okay. 3Shape is only going to use these points to determine the default library it should choose. So I'll start off tuberosity number 1, incisive papilla, tuberosity 2, and then canine 1 and 2. It doesn't matter which side you define as tuberosity or canine 1, as long as you stay consistent from there forward. So for retromolar, center, buccal, and lingual, I can do either side. I'll mark central ridge, retromolar, center, buccal, lingual. But for K9.1, I have to mark that on the same side as the retromolar center number 1. But again, as long as you're roughly in the right ballpark, it should be okay to proceed forward. Next is drawing the boundary for the gingiva. This is what the software is going to use so it knows to warn me if something is crossing the gingiva section. I'll draw this line by clicking this button and just left-clicking points all around the scan. Just keep in mind that this line is not necessarily the edge of your denture base, so you don't have to be super exact about the positioning at this stage. I'll continue next and do the same thing for the lower arch. Another thing to note is this step doesn't have an undo button, so if I make a mistake and accidentally click somewhere I didn't mean to, I can't really fix it, so I'm just going to continue and ignore it for now. Once I've made my way around and finished the line, I'll be able to modify it as needed. Now that the line's closed, I can move any of these points. I can right-click and delete points. Or I can right-click and get into the fast editing mode, where I can draw and close this extra loop at will. And then I'll just proceed next once I'm happy with the positions. After that, we get to the insertion direction and blockout step. On most denture cases, I'm not really going to utilize this step all that much. It allows me to set an insertion direction, but by default it should be set to perform no blockout at all. We want to maintain at least a couple undercuts if possible, so that there is a little bit more retentive surface for the uppers especially. So I'll continue next. And it gives me an extra option to add extra blockout or remove blockout if I applied any. But for this case again, I want this to be as retentive as possible, so I'm just going to leave it unblocked. For lower arches, you're more often going to run into more severe undercuts, especially on the lingual side. So sometimes I will block out based on insertion direction. So I'd set my angle as best I can from view. I can adjust the angle with the cursors if I need to. And if I'm happy with this insertion, I can add the blockout angle, which I'll typically leave at 0 degrees, if at all. This means that anywhere highlighted in yellow or anything darker is going to be blocked out. If you don't want that to happen, just make sure to leave it set to none. If I think that these undercuts are a little bit too severe, I can manually add some blockout with the plus sign tool. It's only going to add up to this 0.5 value that this bar is set to currently. So I can add and fill in a little bit of extra blockout if I think it's going to be too tight. After that, we get to the actual Smile Composer stage. So this is the point where I'm going to load in my anatomy libraries and position everything. By default, 3Shape users will have the Candelor NFC Plus library available, and in addition, 2018 3Shape users may also have the Colzer or Bago libraries. Within these options, you'll have multiple shapes that you can choose from for anteriors and posteriors. And within all of those options, there's typically multiple sizes available as well. After you've made your choice, you can hit the Apply button, and it'll load in that library. You are still able to change this after the fact, but I'm going to minimize this menu for right now. Once you've loaded in your library, it starts you off with the Global Transformation tool over here, where you're essentially moving that occlusal plane that we marked earlier. So I can move that around still if I thought the position was off, rotate it as needed, and it's still keeping all of the teeth in occlusion based on the library. There are some exceptions where certain combinations of anteriors and posteriors of certain sizes may not line up exactly correct due to the different sizes available, but for the most part, the default position should be in occlusion correctly. After you've positioned the overall arch of teeth as needed, you can fine-tune some things with some of the other tools. These next two tools are similar to the arc transformation tool in that they have different contextual uses depending on where I'm looking from and what tooth I'm selecting when I grab and pull it around. This arch setup tool allows me to grab the teeth and position them while it mostly maintains their position relative to each other, though this will function differently as I work on posterior units. Manual arrangement mostly keeps things at the same arrangement to each other, but starts to grab different groups of teeth depending on which unit you're selecting. But for most changes, I find it's best to use the individual setup tool. This one works fairly straightforward for all of its movements. Blue to move in a certain direction, red to rotate as needed. And you also get some extra functions if you right-click on a unit. If I've been moving and adjusting things as needed, and I've created a diastema, I can right-click on this unit and bring it to the mirror plane or the midline, and it automatically jumps back to that position. I usually then have to continue working my way backwards, right-clicking and bringing everything into mesial contact. You always want to start at the midline and work your way back using this function. That way you don't wind up with a diastema or too little space at the midline. As you work on posterior units, you also have extra functions where you can bring it into antagonist contact. This doesn't necessarily mean that it's bringing it into correct occlusion, but it means that it's making sure that it's in some form of contact without it overlapping. In addition, for the second premolars and the second molars, you can also right-click to remove them out of the equation entirely if you want to. If you're on the 2017 version of the software or later, within this tool you will also have another function with this purple dot. It acts as a pivot point on the point of contact. So this point on our lower arch is supposed to be the point of contact to the opposing. So if I use this tool to rotate this unit around, it's keeping that point of contact at the same space. So I potentially might not have to make many adjustments to fix the occlusion, even though I'm moving and rotating this unit around. In addition, to help out with positioning your occlusion, you also have this slider for a color map that shows you how out or into occlusion you are, based on this chart here. The last extra function that I'll use occasionally is the target icon here. What this does is it constantly checks each tooth to make sure that there are no collisions. It'll add little characters defining where the collision is happening. So this unit here has D for distal contact. This one has mesial contact, which matches, And it also has A for antagonist contact. So I would want to bring things out of that by bringing into mesial for both units. Just right-clicking to automatically adjust. And then right-clicking to bring into antagonist contact. Just be careful, because these check marks don't necessarily mean that the position next to each other is good. These are only checking for overlap. They aren't checking to see if there's too much space available. So you still will want to right-click and bring into mesial contact for pretty much every single tooth if you've made some custom adjustments. Otherwise, after you've made all your changes, or if you're okay with the default position, you'll continue next. And we'll continue and work on the denture bases. Starting with the upper, it's defaulted to the line I drew earlier, but now I'm going to refine it a little bit to act as the edge of the denture base. A quick way to do that is to right-click and get into that fast editing mode, so I can just draw my edge wherever I want. Once you've done that, you can set a default base thickness on the left, and if desired, you can add a window opening for the palette if you need it. Otherwise, I'll continue next. It'll warn me about the drill compensation that's being applied, which you generally will continue anyways. And we'll set our edge for the mandibular arch as well. I'll continue and draw this the same way, right-clicking to get into the fast edit mode, and then tapering back my edge wherever I need it. Once you've adjusted that as needed, I'll continue next. Go past the drill compensation warning again. By this point, you may have noticed the green lines that are on all of the teeth based on the library. This is a predefined edge that the software is automatically bringing the tissue to. So usually this default tissue shape is pretty good on its own. The areas where I typically will make changes is I'll usually use this tweezer tool to just pull the interproximal areas to fill in those gaps a little bit more. Oftentimes, depending on the shape of the denture tooth you're using, You may not be able to bring it all the way up, but I'll still usually fill it in at least a little bit, all the way around. After that, I'd continue and make other changes using your plus or minus tools under the wax knife. I might use the plus sign tool at a fairly large circle size and add a little bit more canine prominence. You could use a smaller circle size to add a little bit more of detail all around the edges of the teeth. Or smooth it out as needed if it's too defined. Unfortunately, the software isn't set up to automatically mimic rugae patterns, so if you need to define that, you'll have to manually adjust that yourself. The easiest way to do this is to try and pull up your original scan data by minimizing your shape. That way you can mimic the existing rugae if possible. I'll get a rough shape pattern in this stage. And afterwards, I'd go back in and smooth out these shapes as needed. After you're finished sculpting the gingiva as needed, you can continue next. And you have a couple extra options before we move on to the lower. Because I chose the glued-in teeth matrix option, it is maintaining a minimum thickness under the teeth, right now of 0.8 millimeters. This will vary depending on what denture material you're milling or printing out of. Also defined by how you're producing this is the drill compensation. In the sockets that it's going to make for the teeth, it's going to add extra bubbles of space at corners if you plan on milling this out. This is to make sure most round-tipped milling burrs are able to reach those corners they otherwise wouldn't. So if I'm printing this, I don't need to use drill compensation. I just leave that unchecked and continue forward. After you've reached the lower arch step, we'll typically do the same exact thing. Use the tweezers to fill in interproximal areas as needed, and then define any other bits of anatomy with the plus or minus tools. After you've sculpted your design as needed, I'll continue next again and apply my default settings for manufacturing before I continue next to the save step. After it's finished loading to save and close, I can generate my CAM file and take a look at our final STLs. One thing to note is you'll almost always get a warning like this one, letting you know that it's not going to be generating an STL for the teeth because it's expecting me to purchase teeth to glue in place. Even though it's giving this warning, it is still generating your STL for the denture base. So I'll hit OK, go right-click, Advanced, and explore CAM, or use the shortcut Shift F4 to pull up the folder where our STL files are being saved. And take a look at the sockets that it's creating. After which, in this case, this would be ready to send to a printer, but if I had used drill compensation, I could send the same STL file to the mill.